question, we have air in a closed system undergoes a thermodynamic process from an initial temperature of 300 Kelvin to the final temperature of 400 Kelvin. The specific heat of air at constant volume varies linearly with the temperature, which is given as Cv is equal to 0.7 plus 0.27 into 10 to the power minus 3T. Change in the specific internal energy of the air in the system is, so we have to find change in the specific internal energy of the air, and it is given Cv. Change in the internal energy is given by Cv dt. So we have, for state 1 we have temperature 300 Kelvin. It goes to state 2 which has temperature 400 Kelvin. So let us write this equation. Means U2 minus of U1 is equal to 0.7 plus 0.27 into 10 to the power minus 3 T dt, integrating it from 300 to 400. So it's a simple question, not very much complex, simple integration. So I can integrate it, this part, this part, this part. So it can be written as 0.7T plus 0.27 divided by 1000, taking this in denominator, into T square by 2, 300 to 400. Now it's up to you that you are using calculator. We can do this question directly. We can separate these terms like this for our convenience, and I can write this as 0.27 by 1000 into T square by 2, 300 to 400. This is just for the convenience. Actually we need to avoid a calculator because there is a chances of human error. So if we can solve by using some mathematical tricks, it is far better. So if I solve this now, I can write this as 0.7 into 400 minus of 300. Similarly, I can write this as 0.27 into divided by 1000 into 400 ka square minus of 300 ka square divided by 2. So this is simple 0.7 into 100 plus 0.27 by 1000. We can apply the formula of a square plus b square, in this case a square minus b square. So I can write this as 400 plus 300 and 400 minus of 300. This is simple 70 plus 0.27. Oh, I need to divide it by 2. 0.27 divided by 1000 into 700 into 100 divided by 2. Now it becomes sort of very simple. Now I can cancel this by 3 zeros, or I can multiply directly from here, that this is 70 plus 7 7 is 49, 7 2 is 14, 18. This is 18.9 divided by 2. So this I am doing just to avoid the calculation from calculator. So this is 2 9s are 18, 2 4s are 8, 9.45. The answer is 79.45. So this is the final answer that we have got. So moving on to the next question. It is given that a vertical cylinder piston device contains a fixed mass of gas in equilibrium. The cross-sectional area of the piston is 0.05 meter square. For 150 kilopascal pressure of the gas in the cylinder, the mass of the piston is. So in this question we need to find the mass of the piston. So let us draw a vertical cylinder piston device, which is somewhat like this. So this is cylinder, this is piston. So from the given question, it contains a fixed mass of gas in equilibrium. So there is a fixed mass of gas in equilibrium in this. So the cross-sectional area of this cylinder is given as area is equal to 0.05 meter square. So the pressure of the gas, which is P, is given as 150 kilopascal. So there is an atmospheric pressure on the top, which I can denote it by P naught, which is given as 100 kilopascal. Now I need to find mass. See, this question is very simple. We need to draw a free body diagram of this. So if I draw the free body diagram of this piston, so I have a pressure P, which is exerted at the bottom face, and on the top face there is a pressure P naught from the atmosphere, and the third is the mass of the system, mass of this piston, which is mg. Just apply the force balance. The force due to the pressure is given by PA, so I can write it as P naught A plus mg is equal to PA. I can rearrange it and write P minus of P naught A by G. Already we have the value of G as 9.81. So I have already P. So I can write this as 150 minus of 100 into 0.05 divided by 9.81. See, here the pressure is in kilopascal and I have to convert this into pascal. So I have to multiply this by 1000 because I have to find this mass in kg. So solving, I get 50 into 0.05 into 1000 divided by 9.81. Now you can use calci because somewhat typical. So I got the mass as 254.84. This is in kg. So the answer to this question, the range is given as 254 to 255. So this is absolutely correct.